Hi, this is Dr. John Bergduff, and this is going to be the first of 4 videos on the subject of rigid motions. Rigid motions is a concept from geometry that talks about operations or transformations that you can do on a two-dimensional object that preserve the shape and the size. In other words, that do not change the shape or the size. There are, depending on how you look at it, there are 3 or 4 rigid motions. You'll see that the fourth one is sort of a combination of 2 of the others, which is why that sometimes is listed as not listed as an option, but is considered just 2 of them combined. To illustrate these concepts, these rigid motions, I'm going to use this triangle. And as you can see, this is not an ordinary triangle. It has a face on it. I have named this triangle Spike, and I'm going to use Spike to illustrate the rigid motions. The first of the rigid motions is called translation. Translation means simply to move the object in a specific direction, a specific distance, like this, just to slide it. So slide and translation mean the same thing. Slide is a little bit more everyday word, translation a little bit more sophisticated. So that's the first rigid motion. The second rigid motion is rotation, which is simply taking the object and rotating it through some degree. And as you can see, if you do that, you do not change the shape or the size of the object at all. So that is also a rigid motion. The third rigid motion is reflection. In reflection, you take a line and simply flip the object over that line, whatever it is. So you reflect it, maybe this way or maybe that way. But either way, you're not changing the shape or the size. And so that is also a rigid motion. Translation, rotation, reflection. The fourth rigid motion is called a glide reflection, in which you translate the object and then you reflect it. And as you can see, that really is 2 of the other operations just combined into 1. And so that's why that fourth one is sometimes not given the dignity of a classification as one of the rigid motions. We're going to illustrate all of these rigid motions one at a time and how you can make them happen on paper. So I'm going to switch the camera here, and we're going to start by looking at translation or sliding on this paper. As you can see, I've made a copy of Spike, and over here you'll see an arrow. This is called the slide arrow or the translation vector. Again, 2 words that mean the same thing, depending on if you want to be very formal, in which case you would call that a translation vector, or a slide arrow if you want to be less formal. Basically, what we're going to do is we're going to take Spike and slide him in the direction of and for the distance of this arrow. How do you do that? Well, the easiest way to illustrate that is by using some tracing paper. I'm going to overlay a piece of tracing paper over Spike and the arrow, and I'm going to trace both of them. This doesn't have to be perfect, but I'm going to try to be as careful as I can. Tracing over Spike. Like this. And also tracing over that glide arrow, slide arrow, translation vector. Now, what you simply do is you take your tracing paper and you slide it so that the arrow you drew slides over the original slide arrow, keeping them lined up perfectly so that in the end, they do form a continuous line segment with the tail of the arrow you drew matching the head of the original arrow. And if you slide along that arrow, Spike slides with this in the same direction. And so you can see that idea of translation. Now, how do you get this on the paper? Well, that's where it's useful to have a hard template of your figure, which I created earlier and cut out from some cardstock, because I can take this template of Spike, slide it under the tracing paper until it lines up perfectly with the copy that I made. You can see that's about as close to perfect as anyone can have it be. Just a little better. There we go. Then what you do is you take the tracing paper away, hold Spike steady. Now he's in the position that the tracing paper was in, and you can trace around Spike carefully, and you will see the shape recreated on your paper. Like so. Take that away, and you can see the triangle. Maybe to clean it up just a little bit here and here. And of course, we probably should put the face on there, or he won't really be Spike. So that is the first of the rigid motions, translation or sliding.